Today on the YY family, Grandma's gonna take the salt and me to Scotland where we go back in time to see how a glacial valley was made. My dad shows me how a laser beam travels in a straight line. Then, I go way down underground to see how tectonic plates cause earthquakes to happen. Uncle Micro and I get small and explore Uncle Scopo's eyes to learn about tears. After that, Zygo and Grandpa Matic take me on a trip to see what Venus and Mercury are like. This is gonna be a great day!
Come along with me and meet the smartest family in all the town. The YY family. Mom can make it plain to see that what goes up eventually comes down. The YY family. Come and meet the YY family. We got a lot of real know-how. Grandpa knows a lot about flying. Ask him and I'll show you now. Why do airplanes fly?
When I land, I'll tell you why.
Meanwhile, there's a dragon making some kind of a potion in a vat. The YY family. And Grandma's no stranger. She can teach you all the dangers found in that. The YY family. Max is a mechanical marvel. Why? I know copy kind of guy. Maybe we can show you the answer now. If you want to take a look inside. Everybody's in a lather.
Rushing, wondering what's the matter.
Every person hears a cry.
Rushes to the baby side.
What's the deal? What could it be? Just as the YY family.
Have you ever wondered why the salty oceans, lightning, thunder, what the earth is like down under? Why there's wind and snow and rain? Let earth and basalt explain.
Oh! Is it really necessary to play those bagpipes right in my ear?
Oh, I suppose not. But how else are the kids at home going to know we're in Scotland?
Oh, my. Just look at this glacial valley. Isn't it beautiful?
This what valley?
Glacial. That means this valley has been dug by a glacier.
Wow! What's a glacier?
It's a huge mass of ice that forms when it snows a lot. You see, Victor, the glacier that dug this valley formed about 20,000 years ago, when the Earth was very cold.
Oh yeah, I remember. That was during the Ice Age.
That's right, Victor. Then, later on, the Earth's climate warmed up and the glacier melted. That was about 10,000 years ago.
So now there are no more glaciers?
Well, there are still glaciers on Earth, but they exist only where it's still very, very cold. I'll show you. 20,000 years in the past. And now for a little experiment. We'll put the first stake here, Basalt.
Why are you tying that string to the stake, Grandma?
You'll see. Okay, now follow me. There we are. Now, all we have to do is wait. We'll study this glacier.
Hey, there's water at the bottom.
You see, the glacier pushes down so heavily on the ice that it liquefies at the bottom. It's like when you crush ice cubes into tiny little bits, they change back into water. Now, let's check on our experiment. Basalt, take us forward 2 years. Now, Victor, what do you see?
The string is broken.
That's because the stake has moved.
Well, how could it do that?
Because the glacier has moved. You see, it rests on a layer of water. Its own weight drags it down. Now, look at the other stake.
It's moved too.
Yes, but less than this one, which proves the middle of the glacier slides faster than its edges.
Why?
Because the edges rub against the mountain, and that slows them down. At the same time, the glacier is digging into the sides of the mountain, carrying bits of rock away.
Oh, I can't find my bagpipes!
The good thing, too. Now, let's go back to our time. Look, Victor, in the beginning, the valley was shaped like a V. Then the snow covered it.
And the glacier dug around its edges.
Which in time, after the glacier melted, gave it a shape more like a U, with heaps of rocks torn off the mountain on the sides called moraines.
This is all very interesting, I'm sure, but I wonder what became of my bagpipes.
on with the electronic knack. Machines are his thing, so don't go berserk. That's on the job. You'll find out how they work.
I'm here, Victor. What is it?
I think we're being attacked by aliens.
Oh, not quite. Your father's experimenting with the laser beam.
What's a laser beam?
That's a question for your dad. Come on.
You missed me.
Oh, yeah? Well, that was just a warning shot.
Whoa! What's a laser beam?
That's a laser beam, Victor. A very thin and strong beam of light. But there's a very important difference between a laser beam and ordinary light. Ordinary light scatters in different directions, but a laser beam travels in a straight line.
Why is it straight?
Well, light is made up of tiny little energy grains called photons, and this energy travels in light waves.
What's a light wave?
It's a vibration which carries energy, just like ocean waves. The laser beam waves move like little waves, all in the same direction.
And when a lot of little waves gather,
They form a big wave.
And ordinary light?
It's made of waves which travel in different directions. Its energy scatters in space. Ordinary light is far weaker than a laser beam's light. Now, let's check out how a laser beam is produced.
Yeah, cool.
Can we come too?
Only if you promise to behave.
We promise.
Before we do anything else, let's make sure our eyes are properly protected. There. Now let's see what happens when we turn on the machine. The laser beam is reflected off the first mirror.
It's going back the other way.
Right. And it's going to keep going back and forth between these two mirrors, growing stronger until
It passes through one of these mirrors? How does it do that?
one of the mirrors is semi-transparent. When the beam becomes very powerful, part of its light passes through that mirror. Laser beams give off a lot of heat. Some are even powerful enough to melt metal. In fact, they're used to drill holes or cut metal plates.
and beams can be so precise, they can be used in some surgeries to make very thin incisions.
Hey, Dad, you told me there's a laser beam in the CD player. How come the compact disc doesn't melt?
Well, that's a very small beam which doesn't give off very much heat. Laser beams are also used to read barcodes.
Oh, I know, like at the supermarket.
That's right.
That's not all. Since laser beams are perfectly straight, they can be used to measure great distances.
Sure, like the distance from the Earth to the Moon. You just calculate the time it takes a laser beam to come and go from the Earth to the Moon.
Well, how does the beam get back to Earth?
It's reflected by a huge mirror that astronauts have installed on the Moon.
Hey, it's an earthquake!
I think we'd better get out of here. Zygo, what are you doing with my laser? Oh, I'm just putting on a little laser light show. Hey, take a look. That's good, Zygo, but I think its appeal may be a little, limited. Are you kidding? Just listen to that crowd. They're howling for more. Oh, no. My public.
Have you ever wondered why there's salty oceans, lightning, thunder, what the earth is like down under? Why there's wind and snow and rain? Let Eartha and Basalt explain.
Basalt! 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 Oh, where is that dragon? This is our baking day.
Have you seen Zygo? We were supposed to go fishing.
They're here, in the closet.
I don't want to go fishing. It's nap time.
And I don't like baking. I only like eating.
All right, everyone, it's an earthquake. Get into the doorway. It's the safest spot in the whole house.
Oh, I think it's over.
Oh, I hope so.
Grandma, why are there earthquakes?
Well, take a look at this egg, dear. You see the way the cracked shell is in sections? The Earth's crust is like that. It's made of several separate pieces called tectonic plates. These plates normally move so slowly that we don't feel their movement. But sometimes they knock together. When a plate slips or its edge snaps, we get an earthquake.
I never noticed cracks in the ground before.
Well, that's because they're located under the ground. They're called faults. As the plates push and slide, they cause crevices, volcanoes, or mountains at the surface along the faults.
The Earth moves where there are mountains?
Yes, there are also underwater faults, like those in the Ring of Fire.
What's the Ring of Fire?
It's an area of the Pacific Ocean. Look, the plate under the Pacific rubs against the other tectonic plates around it.
Could we go see a fall, Grandma?
We sure can. Well, here we are, Victor. We're underground at the borderline between two tectonic plates. Oh, relax, Basalt. That was only a small quake. It seems stronger because we're near the epicenter.
What's the epicenter?
That's the point on the surface where the shaking is strongest. It's directly above the point where the two plates clash.
Like that one?
Yes, Basalt, good example. It's time to go. The plate is moving up. Underwater quakes can cause huge tidal waves. Basalt, surf's up!
Nothing like a relaxing day of fishing, huh?
Oh, yeah. Catching something would only ruin the mood.
Oh, I think I've got a bite! You know, Eartha, if you wanted to come fishing with us, all you had to do was ask.
These two guys you can't miss. You wonder what's inside you. These are just the guys to guide you. Come on, let's go. Let's go, let's go. These guys are in the know. Micro wags go full.
Hey, Mom, look what I found. Hey, why are you and Grandma crying?
We're peeling onions.
Well, is that making you sad?
No, Victor. Most people cry when they peel onions.
But I thought people only cried when they were sad.
Actually, Victor, we cry all the time.
I don't.
Let me explain. What I meant was, there are always tears in our eyes.
How come?
Come with me, I'll show you. Victor, let's explore a human eye. Or Scopo's eye, anyway.
Wow! It's like the opening from Twilight Zone.
You see, in order for your eyes to function properly, they have to be clear of things that irritate them. Dust, for example. Well, tears help keep your eyes clear. Check this out.
What are those holes?
They're the tear ducts, and tears flow out through them.
Where do the tears come from?
There's a tear gland above the eye that makes tears all the time. The tears are mostly water, but they also contain a little something extra to kill germs. When you blink, your eyelid works a lot like a windshield wiper, spreading the tears around your eye to get rid of irritants like dirt.
Where does the dirt from the eye go, Uncle Micro?
The dirt washed away by the eyelid ends up along with the tears in the corner of the eye.
Where are we now?
We're in the tear duct, Victor. The tears and dirt are swept through here, down to the nose.
Hey! It's all windy!
Scopo! Breathe through your mouth! Kai!
The nose, huh?
The nasal cavity, where the dirt and tears go. And from here, they pass into the throat. Did you know that we swallow our tears 10 times a second?
No, but I'm sure glad I found out.
I thought you'd be.
But if that's true, how come tears come out of our eyes happens when we cry?
Simple. When we cry, it's too many tears for the tear duct to handle, so the overflow runs down our cheeks.
Okay. Now tell me about the onions.
Well, there are highly sensitive nerves running through your nose. When you peel an onion, it releases a substance that gives the onion its odor. This substance is also very irritating to the eye.
So the eye produces extra tears to wash it away.
Gesundheit.
Well, thanks, Uncle Micro. Gotta go. So, after Uncle Micro explained it to me, I thought maybe if you peel the onions underwater, the stuff that makes you cry won't get into the air.
I think it's working.
Well, it sure is.
Grandma, why are you crying now?
I don't even like onions.
Who has all the answers about the sun and moon and stars? That would be Zygo and Magic. Who can tell us all about the atmosphere and Mars? That would be Zygo and Magic. Pick a spot in outer space, they've been all around the place. Zygo and Magic, here they come.
And we'll need a polarizing filter. Make a note of that.
Polarizing filter. Got it.
Oh, and make sure the oxygen tanks are full, and we'll need to take along some of those moist towelettes.
Morning, Zygo. Morning, Grandpa Matic.
Oh, morning, Victor.
Morning, all. Oh, make sure there's plenty of fuel. Oh, and don't forget the zoom lens.
You two seem to be planning something big. You're not still trying to photograph Venus.
No, we're done with Venus. We're working on Mercury.
Yeah, Venus was a piece of cake.
Yes, a nice, bright planet. Easy to see from the Earth.
Not like Mercury, the big troublemaker. It's only visible around dawn.
So, you going to Mercury? Can I come too?
I knew we'd left something off the list.
We'll be passing by Venus as well, Victor.
Mercury and Venus are the two planets closest to the sun.
They look pretty close, all right.
Well, they're not as close as they look on this drawing. Objects in space are really very far apart.
Venus is actually 27 million miles from Earth.
Here's Venus.
Whoa, it sure is bright.
That's because it's covered by clouds that reflect the sunlight.
When do we land?
Well, we can't actually land on Venus.
Why not?
I'll show you. Take a look at this high-priced computer simulation of what happens when a space probe lands on Venus.
Venus, like the Earth, has an atmosphere. But unlike the Earth, its atmosphere is made up almost entirely of carbon dioxide.
Which is not a gas you want to breathe.
And on Venus, the temperature is about 900 degrees. Whew, that's hot enough to melt lead.
And if that's not enough, Venus's clouds contain drops of sulfuric acid.
That sure doesn't sound like any place I want to visit.
And now, on to Mercury!
Boy, sure am glad I'm a YY. The other kids in the neighborhood only get taken to baseball games.
Ah, and here's Mercury.
That's Mercury? It looks like the moon.
Well, there's a reason for that. Just like the moon, Mercury has no atmosphere to protect it from meteorites. And there's no wind or rain to erode the craters away.
I'm assuming we can't land on Mercury either.
Unfortunately not. Its days are too hot. Over 840 degrees.
Phew, that's really hot.
Yeah, and at night it cools off to 270 degrees below zero.
That's really cold.
Yep, on Earth, the atmosphere helps control the temperature. On Mercury, no atmosphere means it's either way too hot or way too cold.
Well, now let's get our pictures and head for home.
We're back, Mom!
Welcome home. Did you get your pictures?
We, had a, technical difficulty.
He forgot to take the lens cap off.
While you were out, I got you a present.
All right! Thanks, Mom. Hey, it's a book of photographs of Venus and Mercury.
Mercury? Venus? Well, Victor, what'd you learn today?
Oh, tons of neat stuff. I learned that the middle part of the glacier slides faster than it does on the edges.
The glacier is digging into the sides of the mountain, carrying bits of rock away.
I learned that laser beams give off a lot of heat, and some are even powerful enough to dissolve metal. I also learned that earthquakes which happen under the sea are very dangerous because they can cause tidal waves. I learned that some of my tears are swept through my tear ducts and go down through my nose. And I learned that because Venus has an atmosphere of carbon dioxide and clouds containing sulfuric acid, just about anything will melt there.
Sounds like a pretty big day.
It was, but I still have plenty of questions left for next time.